All right. So let me share the. Somebody just came in. How are you guys doing, by the way? You doing good? Are you guys all caught up, or are you a little nervous about maybe getting a little behind? Where are you guys? Are you feeling comfortable about where you are? All right, we've got 20 people, which is good. All right, so we have been working on exponential growth and exponential decay problem. I'm not going to go over on the problem, but next 2 days, what's today? Today's Tuesday. So Wednesday and Thursday, we're just going to do a bunch of a review. Okay, so especially if you have been missing classes in the past, tomorrow, next 2 days is going to be a good day to sum up everything that we've been doing for Unit 3. For Unit 3, we've been talking about exponential growth problem. Let's see, is there any good problem? Like here, you've got 5,000 investing you're going to put the money in the bank. The bank says it will give you 4.25% interest rate. Okay. And then you want to know how much money you will have after, what does it say, 8 years. Okay, so these are the three key numbers that you have to play with. Um, and then exponential function follows y equals a times b to the x power. Yeah, remember that? Excuse me. Oh boy. A represents the initial value, whatever you're starting with. And in this case, it's 5,000, right? That's why 5,000 is there. And B is the rate. Now, in this case, it's a 4.25, but you cannot just put 4.25, but you have to do something with it. There are two things that you have to do, okay? First one thing, you have to divide 4.25 by 100. So you're basically converting percentage into decimal form, right? 4% is 0.04. So 4.25 will be 0.0425. And then we have to add 1 to it because you want to keep all 1 represents 100%, isn't it? Right? This 1 is 100%. This 4 is 4%. So it's a 104%. You don't want to just have a 4%. That means 5,000 will become shrink to 4%, really tiny number. You don't want that, right? Don't you want to keep all 100% of $5,000 and 4% more? So that's why there is 1 in front of it. And then that X represents the time, in this case, 8. Okay. So that's the kind of the nutshell of what we've done so far. Okay. Okay, somebody just came in. So now what we are going to do today is on what's called a compound interest. Okay, now we just briefly, very quickly went over on the banking system problem, right? You put 5,000 in the bank. Bank says it will give you 4.25% interest rate. Now, if you are getting 4.25% just once a year, then that's what the answer is going to be. Okay. But That's not how bank usually works. Okay. Nowadays, you don't get the mail in the bank statement. Usually, it's paperless nowadays. But when I was growing up, when I was, well, 20 years ago, let's say, used to get the bank statement email every month. Right? Uh, in other words, bank will give you interest every month. Now, if the interest is 4%, okay, that's an annual interest. Right? Does that mean that you're going to get 4% every month? The answer is no, right? You are actually going to get, you're going to divide this 4% by 12. Let's see. We do that. Let's do that. 4 divided by 12. So it's like 0.33. You only get 0.33% for just 1 month. But for next month, you're also going to get 0.33%. If you do that 12 times, you will get the total of 4%. So is the answer going to be the same? What do you guys think? This is called a compound interest because not just once a year, but you compound, you slice up the annual percentage into the compound period, and you get that portion of the interest for that, let's say every month or every quarter, meaning every 3 months you get the interest. Every 3 months you get interest. What happens is it's better for you, compound interest, and that's how bank operates, where you get. Why is this advantageous for you? Because you receive interest on the interest that you already earned for that. Let's say the January, you receive a little bit of an interest, right? And then for February, at the end of February, you're going to receive interest of the interest that you already earned. And then for March, you're going to earn the interest of the interest that you've earned for January and February combined. So it grows a little bit better than just once a year. I hope that made any sense to you. Okay. Any questions so far? Have you done this before? I'm guessing that since you've done compound exponential growth and decay, I think you have probably have done this already. Has anybody seen compound interest problem, compounded quarterly, compounded monthly? Have you heard anything like that before? You don't remember anybody? No? Okay, maybe this is something new then. So it's good. So let me walk through the process here. Okay. Now, in this class, we will have only 3 type of a compound problem. It's a compounded half yearly, meaning that you're going to receive 2 times a year the interest. Okay. If you see compounded quarterly, the phrase compounded quarterly, you're going to receive the interest 4 times a year. Okay. And then if you see the words phrase compounded monthly, that means you're going to receive 12 times a year. Okay. So let's begin. Okay. Here's the first question. You've got calculate the final balance of $10,000. So you're going to put the $10,000 in the bank. And the bank says it will give you 6% PA. It means per annum. I think it's a Greek, Latin words, but it means annual. Okay. So PA, so 6% for the whole year, right? But it is compounded quarterly. Okay. Now it is still the same exponential. This is a growth pattern, and you're going to use that. Okay. So that is not going to change. And initial value is going to be 10,000. Okay. But again, the problem is going to be what B, and actually also the time too. Okay. Time is not just going to be 5 years. Okay. You're not going to put 5 in X. You're not going to put 1.06 in B. Okay. Well, if it is just once a year, your equation will be 10,000 times 1.06 to the 5-year, right? And actually, let's figure out how much it's going to be. So your investment will be 13,382.26. That's if you were receiving once a year, okay? But this time it's a compounded quarterly, so it's going to be a little bit different, okay? So how do you do it? Basically, we need to know how to treat this 6%, okay? We're just going to add one additional step, okay? First, 6% is a annual interest rate. You're going to get 6% for the whole entire year, right? However, we're going to figure out the interest quarterly. Okay? You're going to receive, so you have this whole 1 year, right? And you're going to get 6% for the whole entire year. But we're going to split the whole year into quarter. So and that means you have to divide 6% by 4. So let's do that. 6% divided by 4. What do we get? What is it? 1.5? Yeah. In other words, for the first, let's see, what's quarter? That's January, February, March, 3 months, right? Every 3 months, you're going to receive 1.5% interest rate. And then from, what is it, April to the end of June, you also receive 1.5%. And then you get 1.5%, and then 1.5%. Then you will get the total of 6%, isn't it? Right. So the first step is to divide the annual percentage by whatever the compound, the period. In this case, quarter, it's compounded quarterly. So you're going to divide by 4. Okay. Then the next step, I'll actually erase that part. So the next step is the same. Now we're going to convert 1.5% into decimal form. So 1.5% divided by 100, which you will get 0.015. That's 1.5%, isn't it? And then the third step, we're going to add 1 to it. So it will be 1.015. Okay. And that 1.015 is the number for B. Okay. So let's form the equation. Y equals 10,000 times 1.015. Now, let's stop. The time is 5 years. Now, what do you think we need to put in that circle right here? Is it going to be 5? Very good. Now, how do you think Gentry got 20? Do you guys see that in the chat? Where did that 20 come from? Yeah, because now we are figuring out the interest by quarter, right? So you have to count how many quarter period you've got for 5 years. Now, each year is 4 quarter, right? That means 5 times, or what should I do? 5 times 4, which is 20. And 20 needs to take place in for the time, because we are figuring out in quarter system, not yearly system. We want to know how many quarter we've got. So that's 20. So let's figure out. Okay, take out your calculator. 10,000 times 1.015 to the 20th power. You guys all have that? What did we get? Oh, that's just 1, 3, 4, 6, 8. Now, comparing to the once a year 6%, this is definitely better, isn't it? I mean, it's not much, but it is better because you are now earning interest on the interest that you earned for the previous quarter. And then now you're going to earn interest on the interest for the previous quarters and so on. So it adds up. Okay. And this is what's called compound interest problem. And that's actually how a bank operates. Okay. They don't just figure out the interest at the end of the year. They'll figure out the interest every month. I don't know. I have never seen compounded quarterly in the bank system, but I guess you could also have that. Okay. Let's try another one. Shall we do that? Okay. Well, am I giving you guys enough time to write this down? Do you guys need time to? Let me give you a minute to catch up on writing. Or are you guys ready to move on? Okay, who needs more time to write, catch up on writing? You guys taking notes? All right. Okay, let's move on then. I just have one more examples, and let's do the assignment together too as well. Example 2. $8,000, 8% per annum. Again, means annual. So 8% per year. And then for 10 years. Okay. So these are the key player numbers. You guys remember the steps? I'm gonna let you guys work on it by yourself. But this one is compounded monthly. Okay. Can you indicate the answer for example 2? How much will 8,000 be after 10 years? should have picked number that will divide evenly. I guess it's a little too late. I don't want to change the number there. Does anybody have the answer for the example 2? So I'm going to get started. So the first step, again, we need to focus on this 8%, okay? What do we do this time? We need to do 3 things to the percentage. Yeah, I got a little bigger number. Let's see. Maybe because I didn't round off the percentage, I have a way to save that. That may make a difference. We'll see, okay? So now it's a monthly, right? So annual is 8%, okay? So that's a 1 year, and then you get 8%. But you're going to divide 8% by 12. Yeah, you have to divide 8% by 12 because it's a monthly. I mean, basically, you have to ask yourself, how many months are there in a year? And of course, it's 12, right? So you do 8 divided by 12. Maybe we should have done this together, huh? From the beginning. 8 divided by 12, you get 0.6. I hate to round it off, but for the sake of, there's a way to just keep that long number, but let's say, let's just round off for the, bank will never do that though, okay? They have a, so it's 0.67%. You're not even receiving less than 1%. It's 0.67% for 1 month, okay? But for the next month, you receive that. And then if you add that all together 12 times, you're going to get 8%. Second step. Now, even though it is already decimal number 0.67, it is still a percent though. Okay, it's a fraction of a 1%. Okay, but so we need to convert that into decimal form. So we need to divide by 100. You can't skip that. So it will be 0.0067. Are you following this? And now you're going to add 1. So it will be 1.0067. Okay, and that's the rate that we are going to use. So let's construct the equation. Y equals 8,000, that's initial value. The interest is 1.0067. Now to the, what's going to be the exponent? The year is 10 years. Very good. Do you guys all see that in the chat? 120. I know it's a lot, but now because we are counting by monthly, right? So you have to ask yourself, how many months are there in 10 years? You can't just put 10. That means it's 10 months, okay? But 10 years, times 12 months each year. That's 120, right? So we've got to use 120 for the time. So what do we get? Yeah, I don't quite like the number, but that's okay. So if you do that, you get 17827.82. Okay, and that's good. But this is not accurate because we rounded off the percentage right here, you guys, right here. And you don't want, well, okay, right, for this one. But, and I don't think I will pick a number on the test that will not divide evenly. Okay. Let's move on to the assignment portion of the assignment. Okay. Does anybody need more time to write this down? Is everybody good? Okay. Okay, I've got 6 problems. Okay, and let's work on that. I don't know if this will give enough space. Can you guys all see okay? So this is your assignment for today, 3.4. You don't need to copy down all the words word by word. But let's write down the key components of the problem. First, $4,848. Fixed annual interest rate of, so annual interest rate of 5% compounded 2 times per year, half yearly, okay, for 6 years. You guys are ready? So what do we do first? So what do you think you need to do? Again, you need to place our focus on the percentage. First step, we need to split 5% by what? What are we going to divide 5%? We're going to divide it's compounded 2 times per year. So we're going to divide a split 5% by 2, which is 2.5, 2.5%. So at the end of June, half year, right, half of the year, you're going to receive 2.5%. Okay. And then at the end of December, you're receiving another 2.5%. So the total of 5% a year. Okay. And then number 2, what are we going to do? We need to treat the percentage, convert it into decimal form by dividing that number by 100. So 0.025. Okay, don't assume anything. Just make sure that you confirm that, whether with a calculator or other means. Number 3, what do we need to do? We need to add 1 to it. Okay, so it's 1.025. That is the interest rate. So let's formulate the equation. Y equals initial value 4,848. It's a funny number there. Times interest rate is 1.025. And the time, what do we need to do? Don't forget. I don't want you to be forgetting. Definitely, this is going to be one of the choices. It will be a multiple choice test question, right? And definitely, I will be using 6 as one of the choices, but it's not going to be 6, but it is. You're receiving 2 times per year. So 6 times 2, you're going to receive interest 12 times for the duration of 6 years. It's going to be 12. 6 times 2. So the answer will be, is everybody okay on how to punch in the numbers in the calculator? You do 4848 times, okay, 4848 times 1.025. Exponent is either like this button, or maybe some of your calculator may have like a y to the x. Those are all exponent button. Okay, 12. So you're going to get 6,520. Did you get that? Okay. Number 2. This time you do this by yourself. Okay, how do you do number 2? I'll give you 1 minute. You guys getting the hang of this? It's time. Some of you can work on these problems comfortably on your own, so please move on. All I can show you right now. Okay, it's been about a minute. How are you guys doing on this? Okay, so 6%. Again, I'm just going to outline that step, okay? First step, we need to treat 6%, but this time it's compounded quarterly. So what does that mean? You're going to divide 6% by 4. Monthly means you divide by 12. Quarterly, you are going to divide by 4. Biannually, or 2 times a year, that's 2, okay? Or half yearly, I've seen the words anywhere from like a semi-annually, right? That's 2, okay? But let's keep going. So 6% divided by 4, I think we've done that. That's 1.5%. Okay, and then next, you've got to convert 1.5% into decimal. by dividing by 100. 0.015. Then you're going to add 1 to it. So it's 1.015. Do you guys have that? It's very important that you get this number correct. Otherwise, no matter what you do, you're not going to get the right answer. 2,977 times 1.015 to the 13 years. But you can't just put 13. It's 13. Each year is 4 quarter now. Okay. So you got to do 13 times 4. What is that? 52. So you got 52 quarter periods for duration of 13 years. So you end up with 6,074. And that's pretty good, right? Without you doing anything, your $3,000 investment became $6,000. I mean, it took 13 years, but it's if you are able to just leave the money in the bank for that long time, money can grow on its own. And that's what investment is all about, right? You let your money work for you, right? Rather than you working for money. And you think that investment is just for rich people, that's wrong. Okay, you can, as soon as you are able to hold a job, you are able to, start contributing, creating Roth IRA. There are whole kinds of things, all kinds of investment methods. Right? So I hope you look into that. Okay. Number 3. Let's keep going. Again, it's quarterly. Same thing. 8%. 15 years. Now, 8% is rather high for a bank. No bank will give you 8% interest rate. However, you can still achieve about 8% or even close to 10% or even higher return by investing in stock market, mutual funds. So I hope you look into that kind of study those kind of things. You guys okay on this? So let's begin. 8%, divide by again. Okay, so let's write down 8%, divide by 4, which is 2%. So every 3 months, you're going to receive 2%, 2%, 2%, 2%, 4 times. And that's 8%, isn't it? And then 2%, you need to divide by 100. 0.02. And then you're going to add 1. So 1.02. You guys get that? 5,432 times 1.02 to the, what's the time? 15 years. But 15 years times, you got to do 4, which is, what is it, 60? 60, yeah, 60, right? 60. So the time is going to be 60th power, right? Let's figure out. So 17,000, 18,000. Tripled the money over 15 years. Okay, let's keep going. 3 more to go. Are you guys with me? I hope you are. 4 divided by 12. Again, it's 1/3, so 0.33. That's not a good number. How can you change that? Like 6%? Yeah. Well, let's just keep 4%. But this time it's compounded monthly. This is the money. Then 8 years. Okay. Oh, well. You guys doing okay? So you have 4%, but this time you got to divide by what? It's monthly. So you got to divide by 12. And this one is going to give you 0.33, okay? And it just repeats. Actually, you know what? There's a way to save that number in calculator. If you have a graphing calculator, did you guys know that you can save that number? So you go 4 divided by 12. You get that, right? Now you don't. Now, if you need to round off, that's fine, okay? For this class, that's acceptable, okay? So don't even worry about it. But if you're, let's say you're working in the bank, you don't want to round off this percent, okay? You don't want to get rid of all the the rest of the 333. You need those, right, for your customer, right? And well, first, let's divide that by 100. You get 0.00333, right? And then you're going to add 1 to it. So you've got that 1.003333. Now, you can actually save this number. Like, you know, you save your paper, right, on your computer. You can save that, right? And you can do the same thing. You can save this number to a button, right? So what you do is, if you have this graphing calculator, this type of graphing calculator, you see there's a STO, that's a store. It's a saving number. So you press STO right there. And then, so answer, arrow, and then, so you can save it. Good place to save is this X button. Okay. So you go answer goes saves to X, and then you press enter. Then every time you use this X button, the X represents that 1.00333. So you could save that, right? So you've got 2476 times 1.0033 to the, what's 8 times 12? 96. So what you can do is 2476 times so you can type it like that 2.2476 times X to the 96 because now X button represents 1.0033. And so that will be the accurate answer. Which is, what is it? 340795. Okay. And that's what the bank will give you. But if you round it off, 2476 times 1.0033, if you just stop there, then you're going to get 3397. You see how different it is if you round off the percentage. But that's okay. Don't worry about it. You can round off for this class. So 3397. That's perfect. Okay. All right, let's keep going. 2 more to go. I think somebody just came in. Okay, number 5. Let's finish this up. Number 5. Again, compounded monthly. Okay, 6%. That's the initial amount for 20 years. Just going to leave it for 20 years. You know, that's what I do. Actually, you might be thinking, well, how can you not withdraw money for 20 years? Well, I have what's called a IRA, retirement account, and I put money every month, a certain amount. I contribute to that, and the money goes to purchase what's called a mutual fund. Right? And they'll buy the company will buy a stock for me, just collective of a stock for me. And then I will just leave it until I retire for another 10, 15 years. And then, so I've been doing that for many years already. Right? By the time I retire, I should have, hopefully good amount of money to retire on. Talk to your parents about those kind of things, how they are preparing for their retirement. Maybe they have what's called a mutual fund. They have a company retirement system, 401k. sometimes those retirement is not Social Security, that's government retirement system. Country is you spending lots and lots of money, and I don't know if Social Security is going to be there by the time I retire. Yeah. So I'm preparing for another source for my retirement, um, my personal investment. And people do that, right? So as you know, probably retirement is far from in your mind, but it's as you go to college, universities, or start working after high school, after college, start thinking about those. Okay. All right. Let's get it done. Too much of talking. 6%. What do we do? Compounded monthly. So what do we have to do? Divide by 12 again. So what do we get? 0.5%. Remember, it's still percent. Okay, you are receiving half of a 1% every month. So half of a percent. Second month, another half of a percent. That's 1%. Right? If you keep doing that, you will get 6% for the whole entire year. Now we need to convert 0.5% into decimal by dividing by 100. So it will be 0.005. Okay? And then we need to add 1. So 1.005. Is everybody with me? 4353, 1.005. Now 20 years, but we are counting monthly. So how many months is that? 20 times 12. What is it? 240. That's 240 months. So it's 240th power. 4353. You will end up with 14,000. And that's if you just leave a 4,000 and then don't add anything to it, don't subtract anything from it, right? But when you, in reality, when you have a retirement account, you contribute every month. You put money into it. So that means that money will keep growing, keep growing, keep growing. Hopefully that's the idea. Okay. Okay, the last question, guys, and we'll be done. Okay. All right, you guys all done? 4.5% semi-annually. That means twice a year. Okay. For 8 years. So what do? It's compounded semi-annually. That's twice a year. So you got to divide that by 2. 4.5 divided by 2. And what is that? That's 2.25%. Now you're going to convert that 2.25 into decimal form to 0.0225. You okay with that? You guys are with me? And then we add 1 to it. So 1.0225. That is the rate you're going to be using, okay? So 4,996 times 1.0225 to the 8 years, but each year we are going to split into 2 semi-annual. Okay, so that's 8 times 2. So you've got 16 semi-annual period, isn't it, for during 8 years. For 996 to the 16th power. Round off to 40. Yeah. How did it go, guys? Have you done something like this before? Anybody? Okay, well, good. At least there is something that is new, right? It's a very common topic for algebra, maybe not 1, but definitely algebra 2. Okay. And how do you feel about this? Scale of 1 to 5. Hey, I've got this. 5, 4, 3. Yeah. Okay. Very good. So the plan, especially for those who came in late, we will be reviewing for this is the end of the unit, unit 3. So for tomorrow and Thursday, we will be reviewing on compound interest problem, exponential growth, exponential decay problem, and then we will have a test on Friday. Okay, so you guys have a great day. Please make sure that you turn this in, and I will see you guys tomorrow. Take care, guys.